In Lesson 5, we are going to start to lay the foundation for our understanding of functions and their graphs. We've learned about functions and function notation and all the different ways to do this, and we're going to learn a lot about how to graph various functions. And then there's this point where the original graph will change. It can move side to side or up and down. It can kind of twist and turn, if you will. And these movements of the graph, or the position of the graph, is called a transformation. And so really you had a little bit of experience with transformations in geometry. Now, this is technically called coordinate geometry. Anything that is graphed on a coordinate plane with an xy coordinate is called coordinate geometry. And in many cases, you learn most of your coordinate geometry in your algebra classes. So you've had a little introduction to transformations in Algebra 1 and geometry, and we're going to further that knowledge along with this particular lesson. So we have three basic types of transformations that we can use. Translation, rotations, and reflections. Now, in this particular set of notes, we actually are going to take the rotation and we're going to break it up into two. We could either say we're stretching something or we're compressing it. Regardless, it'll move or rotate a little bit, the particular function that you're working with. Now, this has a different look to it depending on what type of function you're dealing with, and so we tend not to use the word rotation so much in algebra as we did in geometry, and so that's why we break it up into compression and stretch. So what you need to do is just to take a look at the bold vocabulary words here and get a very good understanding of what each one of them means. And so you can see that translation simply means a little shifting or a little sliding, and reflection means to kind of flip over a given line or point, and it kind of reflects like a mirror would. So we're going to go ahead and take a look at some possible problems that you might have to deal with, and the skills that you're going to build in this very short set of notes will carry through a large part of the school year in Algebra 2. So let's take a look at sample problem number 1. Now what I want you to do is to pause the video and go through each of the individual questions and see if you can use the vocabulary terms above to help you with the problems. Okay, in sample problem 1, it says to translate the point -2, 5, 3 units to the left and 2 units down. So first things first, we've got to get -2, 5 on the graph if we're going to translate it. So I'm going to go -2x up a +5, and that's a point. Now, we're translating. So if you look at the term for translating, that's a shifting or a sliding of a point. And so we're going to slide it 3 units to the left, which is going to take us 1, 2, 3. So that's 3 units left, but then we're also going to go down 2 units. And so what we've done here, and I'll just put this in kind of so we can see the actual slide that took place. We've gone 3 units left and 2 units down. Now, what's happened here is if I wanted to do this from a labeling system, I could label this point A. So the second point is a translation of point A. What we do is we put a little prime marking there. That's not an exponent, that's not a 1. What that's telling us is that's A prime, and that's showing us that that is the translation of point A, and in this case 3 units to the left and 2 units down. And so it says what is the new point. And the new point, if we look at it very closely, will be -5 and then a +3. And so we have a couple basic questions here so that we can start to make some generalizations about the transformations that we're learning about. It says when you translate a point left or right, how do you change the coordinates of the points? Well, if you notice, when we translated it left, the value that was being changed was the x coordinate. So in this case, the x value changes whenever we translate left and right. And so left and right is a horizontal shift, and so the horizontal axis is an x-axis, so that means our x value is going to change. And so then we have the next question, which would be the obvious question, is what do you, when you translate a point up or down, how do you change the coordinates of the point? And what happens is that's a vertical shift, and that is going to be changing the y values. So in this case, the y value changes whenever we make a vertical shift or an up and down translation. Okay, and so that's a basic first example of what you're going to deal with in translating a point. So let's go down and see if we can look at some other examples. In sample problem number 2, what we've done is we've given you kind of a just abstract figure here, if you will. We've got a handful of segments that are connected together at points that we could consider vertices, and it doesn't make up anything in particular, but we want to reflect this across the x-axis. And so what that means is we want to create a mirror, if you will, a point opposite the given points on the other side of the x-axis. And so what I'm going to do first is I'm going to define a handful of points on the given figure. And so you can see in the table to the right, we can fill in the points of the original function based off the ones that you decide on. So go ahead and try sample problem 2. Try to follow the directions given and see how it comes out for you. Okay, what I'm going to do is I'm going to just define a couple of points, if you will. And so I'm going to say I've got A, I've got B, I've got C, I've got D, and I've got F. And so A is going to be, now if we can count, 1, 2, 3, 4, 5, 6, 7, so that's going to be -7 and a +1 value. And so that's A. Okay. Now you see I have the handful of points from my original function. I just made it easy for myself. I used some endpoints and I used some vertices, if you will, places where the segment changed directions to make it life a little bit easier. Now I want to reflect each of these points across the x-axis. And so what I'm basically going to do here is I'm going to have A prime and B prime and C prime and D prime and E prime. And what that is, I got to be careful here, is basically the reflected point or the transform point from each one of them. And so if I go over -7, instead of going up 1, I can now go down 1, and that's the translated point there, or the, excuse me, the reflected point. So that's -7, -1 for that. And so for B, I'm below the x-axis, so I need to reflect back above the x-axis. Excuse me, I put that in there wrong. That should be a -1, so that this one is actually going to be a +1. Then C is going to be now below the x-axis, and so I'm going to go down -6. Down there, and so that's going to be 0, -6. Again, the same thing with D. It's going to be above, be 5 and a +1, and then E is going to be 3 below. 1, 2, 3, which is 9 and -3. And if I want, I could simply connect those as best I could, and you could simply see the mirrored shape of the original that we have there. And so that's just a good example of a reflection in this case. Now let's answer some questions that go along with this. How do the y coordinates of the points change after being reflected over the x-axis? And if you look at these versus these, you can see a little trend there. And what that trend is every single one of the y coordinates has opposite signs. So the positive ones change the negative, and the negative values change the positive. Now, since we're reflecting over the x-axis, it asks us how do the x-coordinates of the points change after being reflected over the x-axis. So you can make a generalization here that if we reflect over the axis, that particular coordinate type doesn't change. And so there's no change, if you notice, in any of our x-coordinates because we are reflecting over the x-axis. So basically you could use these generalizations, and if we asked you to reflect over the y-axis, that would give us an opportunity to take these generalizations and apply them the same way. And so this is a quick introduction to translations. We will be using these general rules that we've just determined as we work more with given functions.